name's Alan Harney, and I'm the AWS technical lead, and David Jackson here is the cloud architect, and we both work with the cloud computing group at Fidelity Investments. So our team's job is to enable the AWS platform and also to manage all the AWS accounts across the Fidelity enterprise. We're also responsible for enabling Fidelity technologists to be able to build more secure, more scalable, and more highly available applications within AWS. So just go through today's agenda. So what we're going to do is we're actually going to outline exactly some of the challenges that we're facing today in Fidelity and how we're using data to resolve these. So at last year's reInvent, David introduced the enterprise cloud observability solution that his team has created. And we're going to go uncover the key points of that solution. And then on top of that, we're also going to discuss how we've made it easier for Fidelity teams to gain insights into performance of their environments using tools and data that are all available from AWS. And I'm going to talk and I'm going to demonstrate how we're pulling together Trusted Advisor data for the organization. And David's going to talk and he's going to demonstrate Fidelity's cloud operational dashboard. So in Fidelity today, some of the business units were very early adopters of the cloud, and they've actually paved the way for others to follow. What this has resulted in is us having business units now at various different levels of maturity on their cloud journey. And I want to talk about the scale within Fidelity. So over the last few years, Fidelity Investments has significantly expanded its adoption of the public cloud. So we're running thousands of workloads in AWS spread over hundreds of accounts in multiple environments in multiple regions. And we also have hundreds more workloads currently moving to the cloud. And across the enterprise, we have 12,000 developers spread right across the globe. So to be able to manage this type of scale, Fidelity follows a shared responsibility model. So our cloud computing organization manages the overall health and observability of the cloud infrastructure, and this leaves each of the individual teams then to look after their own application's health. So scale really is the heart of the challenge that an enterprise like Fidelity has when we're looking to take full advantage of what the public cloud has to offer. So we needed a way to be able to manage the health of our cloud infrastructure, and we needed a very clear picture of the current events and scheduled maintenance. And we needed a consistent approach rather than each of our business units having to solve the problem for themselves. We needed a way also to be able to assess how those applications that we have deployed to the cloud and how they're performing. But most importantly, we needed to actually avoid unnecessary outages. So last year, one of our business units actually experienced an issue which turned out to be related to scheduled maintenance on a resource within their account. AWS had correctly notified us of this maintenance. However, within Fidelity, this notification didn't get the attention of the correct people. It also highlighted a potential issue with the resilience and fault tolerance. So AWS already provide data, which is key to avoiding outages like this. And our solution was to democratize these type of cloud operational insights. So we needed a way to be able to manage the health of our cloud infrastructure. And we have multiple sources of data from AWS at our disposal. We have AWS Trusted Advisor, which provides us with a wide range of checks to help us increase our fault tolerance, our security and performance, reduce our costs, and also monitor our service limits. We also have AWS Personal Health Dashboard, and which lets us know of upcoming changes or issues that may affect our AWS accounts. We have AWS Support, which provides us with account support case data, what's opened and also what's critical. And then we have our own Fidelity data sources, which provide metadata on our AWS accounts, such as account owners or users or inventory. So as a Fidelity technologist deploying out to the cloud today, there is a need for a single pane of glass to be able to assess how those applications that are deployed out to the cloud are performing. There's no single way of looking at all these data sources in one place. So the data is organized by accounts, but in Fidelity, we're organized by teams and by applications that may span multiple accounts. So our technologists want to know if their application is architected in a fault-tolerant way. They want to know have there any configurations that may impact their application's performance. Or they may want to know have they missed any configurations. Or is there anything they haven't even thought about? And who best to advise us of these things than AWS themselves, who have designed and developed these best practices. We want to make it as easy as possible for Fidelity technologists to succeed. So AWS Trusted Advisor analyzes our AWS environments and provides best practice recommendations designed by AWS themselves. It's like having our own customized cloud expert. So it inspects our AWS environments with an eye on improving things like system performance and reliability, closing security gaps, and also saving money. So we have access to over 100 different checks across multiple services across 5 different categories of fault tolerance, service limits, performance, security, and cost optimization. So last November, AWS actually released Organizational View for Trusted Advisor. And this actually lets us view Trusted Advisor checks for all of our accounts in all of our AWS organization. So now we can actually generate consolidated Trusted Advisor reports in JSON or CSV formats. So by viewing these consolidated reports, we can now optimize for a stronger security position, better performing applications, and a more cost-efficient setup across our entire environment. However, for an environment, I suppose the size and scale of ours, like I mentioned earlier, we actually needed a solution that allowed our Fidelity technologists to be able to consume this data easily. So our solution is built using all serverless AWS technologies. We're using AWS Lambda, AWS Step Functions, Amazon Athena, and Amazon Quicksight. And the solution can be used by all Fidelity technologists to be able to analyze cloud operational data, to be able to drive key insights, and also to drive decision making and planning as we continue to scale. So we're taking these JSON and CSV files and we're uploading them to Amazon's simple storage service, Amazon S3. And we can retain multiple versions of this report here, which give us a snapshot in time. Then we're using AWS Glue, which creates the table schema from the data that's dropped into S3. We're using AWS Lambda then, which triggers each time it detects new data has been added to the S3 bucket. And then on top of that, we're using Amazon Athena to be able to analyze and run queries against these uploaded reports. We're also using Amazon Quicksight to be able to visualize that data in dashboards. And our dashboard is split into 5 different categories, all which are the different categories under Trusted Advisor. So we have a high-level summary report, and then we have individual reports for fault tolerance, service limits, performance, security, and cost optimization. So now I'm going to give you a quick demo of what that looks like. So this is Fidelity's Trusted Advisor Consolidated Report. So all the data that you see here is mocked data. So the summary view gives you a full count of all the AWS accounts that are included in this report. And we can also see a breakdown of the status of these checks. So green indicates that no problems have been detected. Yellow means that an investigation is required. And red means that an action is required. Also down below, the chart on the left shows the total number of checks per category for all of our accounts. And the chart on the right shows the amount of checks being run under each of those categories. So as you can see, there are 48 different service limits are being checked as part of this particular report. Then if we go back up to the top, we can see that we have a number of filters, which allow us to be able to focus in on a subset of AWS accounts. So we can filter on a Fidelity business unit or a subset of business units. Or we can zone in on one particular environment, a production environment or a development environment. We can also focus in on different status levels of checks. So let's look at different checks that require investigation and action. We can also focus in this check on just production accounts. So as you can see, all the summary data before automatically adjusts to reflect this filter. And on this report, we can see that fault tolerance is taking up 92% of these. So let's go over and have a look at that. So in fault tolerance, this is going to highlight areas where we can increase the availability and the redundancy of our AWS applications by taking advantage of things like auto-scaling, health checks, multi-AZ, and backup capabilities. It highlights here EC2 instances, which are unevenly balanced between availability zones. And below that, it highlights RDS instances, which are deployed to a single availability zone. So multi-AZ deployments allow automatic failover to a standby instance if needed. However, these instances here are a single point of failure. So moving over to service limits. So Trusted Advisor checks 50 limits across 10 services. A status yellow indicates that a limit has exceeded 80% of its capacity, whereas red indicates that you've actually hit your limit. So a number of these that an increase maybe need to be requested for it. However, we've had multiple use cases whereby cleanup was just required. We had one team who showed up on this report as having hit their limit for RDS snapshots in a region, but they actually no longer had anything deployed to that region, and this highlighted housekeeping they needed to perform. We had another team who had their elastic IP limit, but they were completely unaware of this fact, and it was due to the way they had performed their last deployment, and this would have most certainly caused them a deployment failure had it not been highlighted and addressed. Moving over to security, access keys that have not been rotated 90 days are highlighted as status yellow, and ones that have not been rotated for over 2 years are highlighted as red. And as we know, this is one of the important steps required in protecting our resources from unauthorized access. Under performance, we have checks for EC2 instances, and it highlights if we have any instances running more than 90% over consecutive days. So consistent high utilization can indicate an optimized steady performance, as was the case with many of the servers that come up in our Fidelity reports, where they're running CPU intensive workloads. But it can also indicate applications that don't have enough resources. Moving from overutilization to underutilization, cost optimization checks for underutilized resources such as these EC2 instances, which use less than 10% CPU, or the RDS instances below that have no active database connections in the last 7 days. This highlights opportunities for people to consider stopping or terminating instances, or maybe scale down using auto-scaling. So the good thing is AWS continue to add more and more checks. And since last month, AWS Lambda now supports 4 new checks to help optimize cost, security, and fault tolerance. And now I'm going to pass you over to David, who's going to talk to you about cloud operational health.
Thanks, Alan. As Alan mentioned, we presented our solution for cloud operations at scale at reInvent 2020 last year. Here's a quick one-slide recap of what we discussed. We created a 2-part solution for a consolidated view of cloud platform health across the enterprise. This included real-time PhD event alerting and analytics capabilities for analyzing historical trends in PhD events, as well as support cases that were created across the organization. So firstly, we created the Cloud Event Processor for those centralized PhD notifications for centralized delivery across all our accounts. This sends targeted communications with additional context that we add to those that need to know about the event. It also serves to reduce noise by giving us the ability to filter out at a central point notifications that we know most development teams can't really take action on. We can also filter out recipients who have opted out through subscription preferences of notifications for particular accounts or for particular topics. So this Cloud Event Processor application gives us a consistent way to handle PhD notifications given our scale of the enterprise, as well as the varying maturity levels that we see across our teams that Alan mentioned earlier. It also gives us improved awareness of the issues that matter by those who need to act on it. We also, secondly, created the Cloud Operations Dashboard. This is a centralized analytics capability for both PhD events and support case information across all our accounts. Both historical data patterns as well as current issues are available for analysis. We are able to identify which issues are most important and float these to the top for greater attention. For example, open, critical, or urgent support cases are highlighted as the most important active issues. Also, scheduled maintenance that's due in the next 90 days is clearly flagged so that we can review and take appropriate action to avoid any outages. This solution has provoked really positive data-driven discussions, both internally within our organization and with our AWS partners. For example, when we want to describe accurately any trends in cloud platform stability that we're seeing. So that was our start, but where did we go from there? What have we learned in the last few months since we launched this solution? And what do we do to improve it? Well, for our analytics dashboards, more operational use cases emerged as partners started accessing and using the insights that we provided. For example, we quickly saw the need to get intraday updates on critical support cases as they progressed. This required more up-to-date data. So we had to reduce our refresh rate for our data collection process from an initial 24-hour cycle to hourly updates. But even then, we found that we wanted to refer to the dashboard for impact analysis during ongoing health events, and hourly updates just wasn't enough. So we moved closer to real-time 5 or 10-minute updates, resulting in the ability to create dashboards for dynamic operational use cases as well as analytics. So let's take a high-level look at the batch process solution that we put together to feed data into those analytics dashboards. And we'll start with the existing system that we had a few months back when we launched. And that system started with a simple scheduled CloudWatch event, initially daily, and then we moved to hourly updates. That CloudWatch event triggers multiple parallel step function workflows. Those workflows coordinate a set of Lambda functions that interact with Amazon's APIs for personal health dashboard information and support case information. Those Lambdas also gather additional metrics or calculate them based on the raw data coming from the APIs. For example, for support cases, we calculate the response time as well as the resolution time of those cases based on the case communications that we gather for each case through the API. The actual response and resolution times aren't available as raw values from the API itself. We save all that information to DynamoDB tables, export to S3 so that Quicksight can consume that data, and we create the dashboards from there. So that was our starting point. But what have we added since then? Well, initially we added a daily update email, and this was actually a really big hit with our partners and the dashboard users, and it gives a snapshot of the current high priority health issues and critical support cases that are currently open. That gives our partners a clear summary of our cloud platform stability and health as they start their day. And this was easily achieved with Quicksight's ability to configure a regular dashboard snapshot report to be sent to readers. As I mentioned earlier, we've moved closer to near real-time updates in the dashboard. We updated our batch schedule from 1 hour to 5 or 10-minute intervals. But Quicksight was limited to 1 hour updates. That was the shortest update cycle that we could configure within Quicksight itself to refresh its data. So instead, we used the Quicksight API to trigger dynamic refreshes of the data programmatically. We trigger a Lambda function when we deliver updated set of data into the S3 bucket, and that Lambda function uses the Quicksight API to then refresh the dashboard itself. And all this enables us to create operational views to manage ongoing issues. For example, understanding how widely we might be impacted by an ongoing service degradation. Finally, we update the dashboard visualizations that we had created based on our partner feedback. We also added new custom dashboards for specific use cases, such as analyzing trends in common service limit requests that were created through support cases. And that allowed us to understand automation opportunities at account creation time. So let's take a look at our main dashboard now. Let's get a tangible sense of the insights that we're able to collect at organizational level. So we start on the Open Issues tab, which gives you a sense of what's happening right now of critical importance across our organization's accounts. And I should point out that, as with Alan's demo, all the data that you'll see here is randomly generated. So on the Open Issues tab, we can see at the top an executive summary of the support cases and the health events that are of critical importance that are open right now. You just get a brief total and description of what they are. Following that, We get a set of the critical and urgent support cases that are active right now, who opened them, what their status is, what the subject is, and what services are affected. We can then look at the active health issues, if there are any, what the issues are, but also which accounts are affected, keeping in mind that a single health issue could affect multiple of our accounts. And then we look at the scheduled maintenance. What are the upcoming changes that could affect our resources in the next 90 days? And we highlight in red the ones that are particularly imminent and need immediate attention to review and make sure we don't have impact. We can delve deeper on the other tabs. On the support cases tab, we get a much bigger picture of the open cases, not just critical and urgent, but all the cases. Various breakdowns of those by service, and also a list of cases that are going to auto-close because we haven't responded saying that the issue was resolved or for more information. We've got various breakdowns of all the support cases we've created, and there are filters where you can filter this by time. Of particular usefulness is the ability to see the response time on our support cases, and especially the critical and urgent cases. Are they meeting the SLAs that we expect from our Amazon partners? And we can see trends over time of that as well. And we can also see the case resolution times as well. So analyze the pattern of are we closing our cases quicker or slower over time? Finally, we can see full details of every case that we've recorded. When we go to the Health Issues tab, we can see similar breakdowns that we saw on the Support Case tab, whether it's breakdowns by service, which are the noisiest accounts, and trends over time. We can also see scheduled maintenance again and the most impacted accounts by the upcoming maintenance. And for each and every health events that we've collected, you can see full details, select one, and see the description of that issue. Final tab is the Service Alerts tab, and this is non-account specific. These are general service alerts that are issued through Personal Health Dashboard as well as Amazon Service Health Dashboard. We create breakdowns of patterns over time, regions affected, services affected, and we can view individual events and again view the precise details over time of how that issue progressed and ultimately how it was resolved. So that's a whirlwind tour of our main dashboard. Hopefully that gives a sense of the insights we're able to derive from both the health and the support case information at an organization level. So finally on this, just a quick note about the cost of this solution. It was important from the beginning, really, to be sure that this was a cost-effective solution to run. Basing our solution on serverless technologies, which follow really a pay-per-use model, fits well with our low-cost goals. In the table here, you see a summary of our monthly costs for this solution. We can see the dashboard costs, but we can see between Lambda, DynamoDB, and step functions, the data collection and the data storage costs ongoing each month for this solution. And in total, the overall cost for that data retrieval and storage is less than $75 a month. And keep in mind that this is data that we're retrieving across a large set of accounts, upwards of 1,000 individual accounts, each combined that generate thousands of individual personal health dashboard events, as well as hundreds of support cases and many associated communications with each case. Overall, that's thousands of API calls we make on a regular basis to pull all this data in. So we see this solution as representing great value considering the scale that we're operating at. And the dashboard usage itself, for users to see their visualizations, they scale equally well given Quicksight's pay-per-use model also. Any registered users of the dashboard who don't access the dashboard in a month, there's no cost. And for those that do, there is a $5 limit per month, and we see an average about $2 or $3 per user for active users using the solution. So overall, the solution scales extremely well in terms of cost. Okay, finally, let's do a quick wrap up. We've seen both from Alan the Trusted Advisor solution, as well as our cloud operations, health and support case dashboard solutions as well. Let's summarize the key benefits of democratizing your cloud operations data and the learnings that we've had since we've done this in our own organization. So the key benefits of this scaled cloud operations approach are data-driven discussions and decision-making. We can now work with our AWS partners on case support quality or platform stability, and we can base those discussions on validated, clear, hard data. Not as before, where on occasion we might have talked about individual issues or anecdotal evidence. We've got the full set that gives us the full picture. We have actually reduced avoidable outages. As Alan mentioned, these happened in the past through a lack of awareness of upcoming scheduled maintenance. Through the dashboard solution, this is now a thing of the past, as our business partners internally in the organization can regularly check this dashboard and take remedial action before the event occurs. We have clear consolidated access to the data that matters in a consistent way across the organization, improving transparency by highlighting critical and important issues first. So what learnings have we had on this journey? Well, number one, we have achieved scale through a self-service model for democratization of our cloud operations insights. A relatively small cloud computing team within Fidelity is able to process and make available a range of insights to a large set of business partners through this solution. Ramp up slowly. We've seen accelerating partner usage over time of this dashboard, particularly the dashboard solutions. But the early period where we had pilot users allowed us to validate the data, improve our visualizations, get them right, and then roll it out across the organization. Democratize the appropriate data. It's fantastic to be able to make this data available to the entire organization, but we do need to limit access for certain information in case it contains sensitive data. One example could be case communications, which, while we resolve critical issues, could involve some sensitive information or private data. So we may not want to share that with the entire organization. And finally, serverless saves. A total compute cost of less than $75 a month, and including data storage for this solution, represents extremely good value. So where are we going to go next with this solution? We're going to continue to work with our internal business partners. We're going to continue to understand their needs and adapt our solution to meet those needs over time. Very importantly, we're going to continue to work with our AWS partners, as we have done up to this point. AWS constantly provide a range of solutions and new solutions over time. And we want to make sure that we build on top of those, not reinvent the wheel. For example, AWS recently released a central organization cloud personal health dashboard. And we want to build on top of that rather than trying to repeat that. So on behalf of Alan and myself, I want to thank you for taking the time to hear about our journey in terms of democratizing operational data for the enterprise. Thank you.